All right, we're going to do two things today. The first is just to introduce the next section that we're going to cover, which is 8.6, the law of sines and the law of cosines. After that, we are going to review a little bit because there will be a quiz tomorrow over 8.4. That was all of our trig stuff, right? So this stuff will not be on the quiz tomorrow, but we are going to start to cover it today, not getting too deep into it. So far, what we've done is we've worked a lot with solving and working on right triangles, but we haven't really looked at what would happen if we were given some other triangle that were not a right triangle. So we had some triangle, we'll call it A, B, C. Now, if we have triangle ABC, the side opposite A across from A is usually called A. The side across from B is usually called B. The side across from C is usually called C. Right? So we have angles A, B, and C. We have sides A, B, and C. They go across from the angle that they're given. Now, if we wanted to solve something in this triangle, again, B is not a right triangle. ABC is not a right triangle. So we can't just say that A squared plus B squared equals C squared, right? In fact, ABC looks like it's probably an obtuse triangle. So we know that in this triangle, A squared plus C squared is going to be less than B squared, B looking like it's probably the longest side, right? So how would we work to solve this instead? Well, let's take a look. If we added in an altitude here, all right, again, an altitude goes from an angle, from a vertex, and is perpendicular to the opposite side. Now we have two small right triangles in this diagram, right? We called this point D. So we have a right triangle ABD, and we have a right triangle CBD. Okay? And just to give BD a different name, a lot of times in a triangle, the altitude is called the height, right? So we'll call it H today. Now, what we're going to do is we're going to make a comparison of our sides here. So with just the information we have a small triangle here that we're looking at on the left. H is the side that is opposite A, right, in a small triangle. And C is the angle that is the hypotenuse. Sorry, the side that's the hypotenuse. Right? So we have the sine of A has to be equal to the opposite over the hypotenuse, right? And that stays here. This is a true statement, even though we aren't talking about from our original triangle, right? Well, what does that mean H equals? Well, H is, if we take C multiplied on both sides here, we get H equals C sine of A, right? Okay, so what about for C? H is the opposite, A is the hypotenuse. So we have the opposite over the hypotenuse again. So the sine of C is equal to H over A. Well, what does H equal then? Well, H is equal to A sine C. You might notice that's a little weird, right? We have C sine A and A sine C. But the other thing, the actual more important here thing that we're setting up is that we have two different things for H, right? But H is the same value in both of them. So we have two different ways of finding the same length. In both of these, H is the same. And so we can actually set these equal to each other, right? So C sine of A is equal to A sine C. And if we divide both sides by AC, might seem weird to do that, but there's a good reason for it. We'll see here in a second. The C's here cancel out, and we get the sine of A over A. And here the A's cancel out, we get the sine of C over C. Sine of A and A are both in our original diagram. Sine of C and C are both in the original diagram without H. And so this will actually be able to solve sides for us. Now, from extension, without having to do all of the extra work, this also means that these are equal to sine B over B, right? So that proportion, that ratio is also true in this set, right? Usually you're going to see it written out in order. So you'll see sine of A over A equals sine of B over B equals sine of C over C. And this is called the law of sines. It is how we solve for sides and angles in a non-right triangle. All right. There is a law of cosines as well. So if we're using the original diagram we had again, the law of cosines, it actually says 3 different things. However, if you know one of them, you're going to basically know them all. And we'll spend more time on it tomorrow anyway. It says that a squared, so the side opposite a squared, is equal to b squared plus c squared minus 2 times bc cosine of A. So we have the A's first and last, b squared plus c squared minus 2bc. So what you'll notice here, that the first part is very, very similar to the Pythagorean theorem, except we're not dealing in a right triangle, so we have to change it a little bit, right? That's the only one that I think you have to write down, but it would follow that this is also true and this is also true. A few notes here. A squared equals b squared plus c squared. Those are all the sides, right? Those are all sides. Minus 2bc, bc are sides. The only place the angle is showing up for the law of cosines is this last part, the cosine of angle A, the cosine of angle B, the cosine of angle C. All right, we're going to come back and use that more on Thursday. So this is just an introduction for it. We're going to spend the rest of the time today on is review for tomorrow. You do have a quiz over 8-4 tomorrow. I'm hoping that a shorter quiz over one section might be easier for us. So be prepared for that. The assignment for tonight will be on the review, not what we just did. So let's see. Express each ratio as a fraction. And decimal. to the 100th. So if we have a triangle, again, we're going back to right triangles here, 5, 12, and 13. I might ask questions like, what is the sine of angle C? You'll come to C. The sine is the opposite over the hypotenuse. And so that would be the fraction. If you're getting the decimal, you're just putting 5 divided by 13 in your calculator, and you're probably getting about 0.38. Again, it is to the 100th, so we want 2 spots after the decimal place. If I ask for the cosine of C, cosine is adjacent over hypotenuse, that's 12 over 13. Right? And that is about 0.92. Or I could also ask for the tangent of A, just to make it interesting here, right? The tangent of A is the opposite over the hypotenuse, that's 12 over 5. This time it's not about equal to, it is actually exactly 2.4. And so we can leave it like that. All right, and the last two that we'll look at. So, the right triangle. So angles to the nearest degree. That's a whole degree. Sides to the 10th. So if we're given a right triangle, sides of 3 and 4, and we'll call this triangle ABC. To solve means to find all of the parts, so BC, angle B, and angle C. Right? What you should do is pause the video and actually try to do that. If you absolutely don't know how, then just keep watching. But if you don't know how, that means you have a lot to study before tomorrow, because this will be a major part of the quiz. So finding BC might be the first thing that we do. This is a right triangle. That means the Pythagorean theorem works, and BC is the hypotenuse. You might also just call it A because it's across from A. So we could call it side A. Right, so this is 3 squared plus 4 squared equals A squared, or 9 plus 16 equals A squared. 25 equals A squared. Taking the square root of both sides, we get A is 5. Next, solving for one of the angles, we can solve for B or C next. Given the information that we started with, if we're solving for B, we have 4, which is the side that is opposite, and we have 3, which is the side that is adjacent, right? So if we're dealing with the opposite and the adjacent, we are dealing with the tangent. We're looking for an angle measure, and the inverse is what finds us angle measures. So the tangent inverse of 4 over 3 will give us B. And if you type that into your calculator and round to the nearest whole degree, we get about 53. Now to find C, you can just subtract from 90. C is about 90 minus 53, which is about 33. 7. You could also use another tangent inverse of 3 over 4. You'll find that that also is 37. All right, what if we were only given one side and my apologies, I have no idea if I was showing any of that the whole time. So there is the work. So again, to find the side, we use Pythagorean theorem. And then 4 over 3 is the tangent, right? Opposite over adjacent. To find an angle, we use the inverse. So we have the tangent inverse of 4 over 3. Calculator gives 53 for that. To find C, which is the opposite, right? 90 minus 53. Or you could use the tangent inverse of 3 over 4. All right, for our last one, we should be able to find angle C, right? It is 90 minus 35, which is 55. The three angles of a triangle must sum to 180, and 180 minus 90 is 90, so B and C must sum to 90. Right? From there, we're using the sine, cosine, and tangent. 3 is the side that is opposite 35, right? We also know that this is 55. So we might say that we're looking at 55. C is the opposite over the adjacent, right? So tangent of 55 is opposite over the adjacent. So C is 3 tangent 55, which is about 4.3. Now you could go and use the Pythagorean theorem with 3 and 4.3 to solve for BC. I'm okay with that. Really, it's better to use a trig function here. So if we use the sine of 35, that is the opposite over the hypotenuse. Opposite over the hypotenuse, which is A. Right? Multiply both sides by A. And we want to solve for A, so divide by sine of 35. And we get A is about 5.2. All right, that is all for today. Your homework is on page 579. And it is numbers 17 to 21. That's due by 8 tonight. And you have a quiz on just 8.4, not the stuff we covered today, tomorrow.